So my name is Rasmus Astrup. I work here at NIBIO in Norway, and in SPADE we are responsible for the Forestry pilot. NIBIO is an independent research organization working with supporting sustainable forest management through the use of digital technologies. In SPADE, we'll try to see how we can improve or support forestry with drones.
The different drones are going to be used for different purposes in forestry. To start off with, you'd have a small drone like this. This is a commercial drone. Many people would have seen something like this before. And this would be great for just getting out in the field, collecting data set and coming back. They're small, they're compact, they're easy to use, they're inexpensive. On the flip side, however, you're going to have much more limited flight time with a drone like this, so you're not going to be able to map as significant an area. And typically you'd only have a camera sensor. This drone here would be an example of a medium-sized drone, a little bit larger. This will give you much more flexibility in terms of the different payloads you can carry, longer flight time, you will fly at higher altitudes. And so with something like this, you'd be able to, for example, mount a more expensive LiDAR scanner on board, which will give you a much more comprehensive 3D view of the forest environment over what you might get from a camera system. Here we've got the fixed-wing drone, and this drone is quite interesting because it's a fixed-wing drone. It means that it's much more energy efficient when it flies. It's able to use the lift generated from the wings, and that means that you're able to cover large areas with this drone and really map out extensive areas at higher altitudes with a drone like this than you would be able to do with a quadrotor.
Yes, so of course the drone is important, but when you want to collect information about forests, really what matters most is what sensor you have on the drone. The sensor is basically what collects the information. So most drones today, they have a simple RGB camera, such as this drone here. Basically collects normal images as you fly along. And that type of data is very important because it can give you a rapid overview of the area you're working, in the forest you're working, and it's easy to interpret and understand. You can also develop different algorithms that detect different features in these images. That can be individual trees, so it can be disturbance to soil after harvesting, or it can be different biological features that you're interested in. The challenge with the cameras is, of course, that they do see the surface of the forest. They do not see through the forest, so you don't see under the canopies. You only see the top of the canopy. And really, forests are a three-dimensional ecosystem. They are complex, and the three-dimensional structure are very important for how they function. If you want to see through the canopy, you have to go to laser scanners. And here we have 3 different laser scanners, and laser scanners are basically a system that shoots out individual laser beams and measure the distance to where it hits something. That means you get this three-dimensional point cloud from a laser scanner.
This drone was developed by SDU in Denmark as part of the SPADE project, and it's one of the drones that we'll be using as part of the Forestry pilot in SPADE. What makes this drone fairly unique is that it is quite small. It weighs only about 2.5 kilos, but it features a full GPU-enabled PC on board, and it has a full 360-degree LiDAR scanner also on board. It's able to collect very valuable data of its surroundings. And so because it's so small, we're actually able to fly it below the canopy in and amongst the understory of the trees. And this allows us to collect very valuable data from actually within the forest that would otherwise be lacking from an above canopy scan. So how we're actually going to be using these drones is we're going to be programming them to fly autonomously through the forest. And how they're going to do that is they're going to use the LiDAR scanner on board, and that's going to allow them to sense the environment. And then they'll use that sensor data to build up a map of their environment in real time with the onboard PC. And using that map, they can avoid collisions with trees, with branches, and other obstacles that exist in the forest, and decide where to explore next to complete the map of the forest. Now, mapping out an entire forest is a big job. So to speed this up, we want to do this as part of a swarm. So we'd have many of these little drones going through a forest all at the same time and building up a map together of the entire area. And to coordinate all these drones, we're going to have a master drone that flies above the canopy, has better cellular and Wi-Fi connection, and is able to stream in data from all the different swarm drones, build up a map, and then at a very high level decide where the swarm drones should be going to complete the map of the area in the most optimal manner possible.
To combine data from above and below canopy drones is extremely valuable.
we're able to use novel AI algorithms to get details on individual trees, such as size, species, and more. From the below canopy data, we get far more information about the health of the forest and are able to see key biological indicators like deadwood, ground vegetation, and more.
So what we discussed so far is mainly using drones for collecting better information for supporting sustainable forest management. The next step for us in SPADE will be to use drones for actually interacting with the environment. We see that as the next frontier of using drones. So that means that drones don't just collect the information, but will actually carry out some of the work. That means we move from drones as a passive collection device to actually towards a robot that actually interacts with the environment. So examples for that will be planting of trees or carrying of equipment to different sites in the forest. But for more information on that, you'll have to stay tuned and follow SPADE on different social media channels.